I'm trying to explain the concept of center of gravity and centroid in this video. So this is about center of gravity and centroid. I would recommend you to go through the videos where we discussed principle of moments here, because the concept of center of gravity and the concept of principle of moments are almost the same. So if you got a better understanding of principle of moments, then it will be easy for you to understand the concept for center of gravity and centroid. So if you haven't already done so, please go through this video here before proceeding further into the video of center of gravity and centroid. So in the video where we discussed the principle of moments, we derived an equation that a resultant force into R is equal to force 1 into R1 plus force 2 into R2 plus F3 R3 plus etc. You know that this force is the sum of all these component forces. It's a vector sum, but still that is the sum of these forces. So you can also rewrite this equation as summation I equal to 1 to n Fi into R is equal to summation I equal to 1 to n Fi Ri. Or you can rewrite again as R is equal to summation I equal to 1 to n Fi Ri over summation I equal to 1 to n Fi. Let's call this equation 1. So this is the equation for principle of moments. Just to remind you, the principle of moment states the moment of a force about any point will be equal to the moment of the component force, sum of the moment of the component force about the same point. So if you have F1, F2, F3, etc. up to Fn forces, then the sum of moments of these forces about a point will be equal to the moment of the resultant force about the same point. So what we are finding out here is the distance of the resultant force from a point. So this resultant force is the sum of all these forces. Now, how can we relate this to center of gravity? Let's see what center of gravity is. Let's consider a body as shown in here, and let's assume the masses the axis x, y and z. Now you know this body will be composed of so many particles. It will have particles in it, and if this body is placed in a field of gravitational attraction, then each of these particles which are having a mass will be subjected to the pull of the gravitational attraction, and therefore they will have a weight or a force, and you know that force will be acting in the direction of the gravitational pull. Let's assume the pull is towards in this direction. So now what we have is a force system where you have number of forces acting parallel to each other, and you know if there is a force system, you will have a resultant force. Let's call the resultant force is acting from here. Let's say it's acting from here, and the resultant force is acting vertically down, and this is Fr. Now you have F1, F2, F3, etc. up to Fn here, and you have the resultant force now. And the point through which the resultant force of a body act, or the resultant force of the body originates, is called the center of gravity, COG. And in this case, the resultant force will be the total weight of this body. So you have too many particles with a mass. If they are placed in a gravitational field, then they will have a weight. A weight is equivalent to a force. So these masses will create a force system, and the resultant of that force system will be acting from a point, and that point is called center of gravity. Now let's say the mass of each of these forces are dW, or the weight of these forces are these particles are dW, and this is W. Fr, let's call this W, and this is dW1, and etc. And let's say the distance from Z axis to the resultant force R is Z bar, and each of this is Z1, Z2, Z3, etc. So if you take the moment of these forces about this axis here, it's not actually moment. It's a similar equation to the principle of moments. So we can write W into Z bar, which is the distance to the resultant force from Z axis, is equal to summation I equal to 1 to n dWi Zi. Or you can also write summation I equal to 1 to n dWi into Z bar is equal to summation I equal to 1 to n dWi Zi. Now you know the similarity of this equation and the principle of moments equation, and you can say Z bar, which is the distance to the center of gravity of the body from Z axis, is equal to summation of I equal to 1 to n dWi Zi divided by summation I equal to 1 to n dWi. And here this will be the total weight of the body, which is W here. And if you are dealing, this is a case when you deal with masses. So if you are dealing with an area or a volume, all you need to change is, if you are dealing with an area, dW1, this dW will change to dA, and this will change to an area. And if it's a volume, then this will change to dV, and W will be volume. So, and in those cases, this distance will be, or that point is called centroid. Area or volume, then it's not a center of gravity because there is no gravitational field. It's only an area. There is no mass in it. So if you are dealing with area or volume, then the center of an area or center of a volume is called a centroid. And then you need to change dW to dA or dV accordingly. And again, if you are taking or if you are finding the centroid based on x-axis, then Z will change to x and Z bar will change to x bar. About y-axis, this will be y and this will be y bar. So for a centroid, if you are finding a volume, you will have x bar, y bar and Z bar. And if you are finding an area, you have x bar, y bar, or x bar, Z bar, just two axes, because for an area you only need two axes. So center of gravity is the point through which the resultant force or the resultant weight or the total weight of the body is acting, and centroid is the point through which the area of a body is concentrated, or a volume of a body is concentrated. So that's a center of area and center of volume. Now, how we are going to find the center of gravity or centroid in a case where we deal with different shapes in your calculations? These are the standard shapes for which we already know, or I'm sure you must have studied this in the previous classes, where if you have two symmetries, then the centroid or center of gravity will be at the intersection of that axis. So here this will be your center of gravity, and in this case this will be your center of gravity, and here this will be your center of gravity or centroid. So for standard shapes like circle, rectangle, square, or different shapes, you have if you have two axes of symmetry, then your centroid will be at the intersection of those axes. And again, if you have only one axis of symmetry as shown in the figure here, then either x bar or y bar is fixed here. Again, that depends on the axis you select. So if you have your x or y axis here, and your x axis here, then as you can see, this is, let's say, this x, and let's say this y. Now you can see this shape is divided into two equal parts by a line which is drawn parallel to the y-axis, and therefore your x coordinate of the centroid is fixed, which is this distance. So this is your x bar, and you know, because this is an area, a two-dimensional case, you only need to find two coordinates. You need to find your y bar, and that y bar will be lying somewhere in this line. So how we can find a y bar, and what is a procedure for finding a centroid of an area or a volume? It's pretty much similar to what we did just before, and let's just try to make or derive an equation for that. As you can see, there is an random shape shown here, which is an area obviously, and you have your x and y axis here. What we are doing is we divide this shape into standard shapes. So we are assuming shape 1, 2, 3, etc. up to n are all standard shapes. It's basically integrating. So we are assuming 1 as a rectangle. So you know, the centroid of a rectangle will be the midpoint of the intersecting axis. So that's your centroid of area 1, and centroid of 2, and centroid of 3, etc. So this is your x1, x2, y2, and this is y1, y2, and y3. And let's say this is a centroid of the body, and let's call that distance x bar and y bar. This is your x bar, and this is your y bar. And now if you are going to find x bar, then and this is a centroid for an area, then you will have x bar into a is equal to x1 a1 plus, let's say, this dA1, x1 into dA1 plus x2 into dA2 plus etc. up to xn dAn. Or you know, this area is the sum of all these areas. So again, you can change that equation as summation I equals 1 to n dA x bar dAi x bar is equal to summation I equal to 1 to n dAi xi, or you have x bar is equal to summation I equal to 1 to n dAi xi over summation I equal to 1 to n dAi. And you can write the equation for y bar as y bar is equal to summation I equal to 1 to n dAi yi over summation I equal to 1 to n dAi. Also you have z bar is equal to, same, just replace this x with z. So that's all you need to do. You can find x bar, y bar, or z bar, or any distance to the centroid of a body using this equation. And again, if you are finding centroid of a volume, this will change to dV for volume, and again this will change to dV. Now going back to a standard shape, not a standard shape but a combination of two standard shapes. Let's see how we can find the center of gravity of a problem here. What you have here is a combination of two rectangles, a T, and if you want to find the centroid of this shape, let's say this x and y, you need to define the axis, and these axes are called reference axis. Because based on this axis you're going to find the centroid. And in this case again you can see this shape can be divided into two equal parts using a line that is drawn parallel to the y-axis, which means your x coordinate of the center of gravity or centroid is fixed, and that will be the distance here. So this is fixed, and that's your x bar. Now you need to find the coordinate of y bar. Let's say the centroid is here, and you need to find the distance to that point from the x-axis, and that's your y bar. So for that what you're going to do is just divide this body into two non-shapes. Let's divide it here, and let's call this area 1 and this area 2. Now your y bar is a1 y1 plus a2 y2 divided by a1 plus a2. It's the same equation that we just derived above, where a1 x1 plus a2 x2, that is what summation I equal to 1 to n dA xi, and a1 plus a2 plus a3 etc. So it's just the same equation, and you're just replacing with y bar because you've got your x bar already established, and you just need to find the value of y bar. Now what is the values for y1 and y2? You know this is a standard shape, therefore y1 will be the distance to the center of area 1 from x-axis, which is the distance here. This will be your y1, and y2 will be the distance to the center of the area 2. So this will be your y2. And A1 is the area of shape 1 and A2 is the area of shape 2. And in case if you are using the body in a different shape like this, let's say if you are finding a shape like this, and you want your reference axes are like this, x and y, then you can see the symmetry axis is passing through here, and therefore your y bar is fixed, which is this distance, and then you need to find the x distance of your center of gravity. So in that case, this equation will be changing to x bar, that is equal to a1 x1 plus a2 x2 divided by a1 plus a2. So that's just depend on the reference axis, the axis you select. So once again, going back to the original equation here, you have an area, you need to define your reference axis, and you can divide the area into number of shapes, and you have to assume, or you have to make sure that you divide in such a way that your shapes are standard shapes. As here you have divided this body into two, where you have a standard area 1 and a standard area 2. You can also divide it like this. If you have a shape, a T shape like this, you can divide it like this, and you can have 3 areas, 1, 2 and 3. Again, this is a rectangle, this is a rectangle, and that too is a rectangle. So you can divide it this way as well. And then you need to find the smaller areas and their corresponding x and y distance from the axis, and then apply any of this equation. You can find the centroid of an area. We'll do some example problems in the next videos.